Okay, so we're going to practice drawing Lewis structures, but sometimes what we're going to draw has a charge. So, for instance, let's look at the ammonium ion. The ammonium ion has a positive charge. Again, this is going to be covalent bonding because we have all nonmetals, but it has a charge here. Well, a positive charge indicates that you lost a negative electron. And so when we do our counting of valence electrons, we're just going to subtract one because of that positive charge. So we're going to subtract one electron from what we have. So let's go ahead and draw ammonium. All right, so let's start with how many valence electrons do we have? Well, nitrogen has 5. Hydrogen has 1, but we have 4 hydrogens in our molecule, NH4. And because of the positive charge, we are going to subtract 1. All right, so 5 plus 4 minus 1, we have a total of 8 electrons to work with. Now, we're still going to do the want just the same way, and the charge doesn't matter here. Nitrogen wants 8. Hydrogen, now be careful, hydrogen doesn't want 8, it wants 2, and we have 4. And so we have a total that we want 8 electrons. Well, we don't have what we want. Take the difference between we are short 8 valence electrons, or we're going to have 4 shared pairs. Now, hydrogen is always on the outside of a molecule because remember, it can't be internal because it can't have more than 2 electrons. So our central atom, what's in the center, is going to be the nitrogen and 4 shared pairs connecting it to the hydrogen. Now, if we look at this, every hydrogen has 2 electrons in its outer shell, and nitrogen is seeing 2, 4, 6, 8 electrons in its outer shell. So we should have 8 electrons, and we do. Now, what we do with our Lewis structure to indicate the charge is you put it in brackets. So you put the whole thing in a bracket, and then on the outside, you put its positive charge. Okay, so that's what we do when we have a positive charge. So for a negative charge, that indicates that you have gained an electron to the number of valence electrons that you have. So let's go ahead and look at this. Carbonate, CO3 2 minus. We're going to start with how many valence electrons do we have? Carbon is 4. Oxygen, we have 6. We have 3 oxygens, so times 3. And then our charge is a negative 2, so we're going to add 2 electrons. Remember, electrons are negative, so that's why we're adding 2 electrons. We have 24 valence electrons. Let's go ahead and see what we would want for everything to have an octet. Carbon wants 8. Oxygen wants 8, and all 3 oxygens want 8. And let's see, that's 32 electrons. We are short 8 electrons, or we're going to have 4 shared pairs. All right, well, carbon is going to be in the middle, and our electronegative oxygen is going to be on the outside. And we only have 3 oxygens, and so I'm going to draw the 3 oxygens just kind of equally spaced around that carbon. And then we start drawing our shared pairs. 1, 2, 3. Wait, we need to have 4 shared pairs. When we have more shared pairs than we have elements around our central atom, that means that you're going to have a double bond. And so I'm going to go ahead and put a double bond. Now, carbon has 8 electrons. This oxygen has 2, 4, so let's go ahead and finish, giving it 8. This oxygen has 2, 3, 4, 5, 6, 7, 8. That oxygen has 2, 3, 4, 5, 6, 7, 8. Let's go ahead and count up our electrons and make sure we have what we said that we have is 24. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Great. Remember that that bond represents 2 electrons. This carbonate ion has a negative charge, so we're going to put it in brackets and put its charge outside. Now, some people are probably asking, why did I put my double bond here? Why did I not put it here or here? And the answer is, it really is in all 3 places. That double bond is resonating around. It's here and here and here and here and here and here. There's no one structure that can represent what this looks like. And so let's look at what we call resonance structures. It is when you can draw more than one Lewis structure for a molecule. All right, now let's go ahead and show you how we're supposed to do that. All right, so for this carbonate ion, this is one resonance structure. Now, to show the other resonance structures, you draw an arrow, and it has a double arrowhead. And now you draw the double bond in another position. And there we go. And there's one more place that that could be, and that is in this position. So what I am doing is I am drawing all the resonance structures for the carbonate ion, and basically the Lewis structure is a combination of all of these resonance structures. So that is the absolute most proper way to represent what's actually happening in this carbonate ion's Lewis structure. I like to think of this double bond a little bit like a propeller, where it's here, 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 here. And the way we represent it is by drawing all the resonance structures. All right, have a good day.